Okay, so I want to cover some more advanced partial derivatives for the first order case. So we haven't covered higher order derivatives yet, and we'll do that later. But I would like to discuss advanced partial derivatives first. So what are we going to talk about in this video? Well, I want to talk about an example where we need to use multiple differentiation rules in order to find partial derivatives, and then I also want to go over implicit differentiation for partial derivatives, which you'll actually see is a very easy task, so it shouldn't be too much of a bother. But anyways, yeah, this is a very important topic, partial differentiation. We'll be doing it a lot, but again, it's really just reworking a lot of the rules that we learned earlier, so the product rule, the power rule, the quotient rule, the chain rule, the log rules, the exponential rules, probably logarithmic differentiation might come back. All of those fun things. Just want to make sure that we still know those as we go into more advanced topics, because we're not going to be spending a lot of time talking about how to take partial derivatives, since that's fairly trivial, actually. Okay, so let's cover some more partial derivatives today. First example I want to do is to find the partial derivatives of sine of x over 1 plus y. So you can see here we have two variables. We have x and y. So what we will do is we will find the partial x of f and partial y of f. So how do I find partial x of f? Well, I hold y constant, so I've essentially got sine of x over c, x over a constant. Well, that's fairly easy to do. When we differentiate this, we take the derivative of the outside function, so cosine of the inside function, x over 1 plus y, times the derivative of the inside function, which is just 1 over 1 plus y. It's fairly easy. Now we do derivative with respect to y. We still get the cosine of x over 1 plus y. That stays the same. But then we need to multiply by the derivative of the inside function. Because 1 plus y is in the denominator, we need to use the chain rule again. We get negative x over 1 plus y squared. So that's the derivative with respect to y or the partial derivative with respect to y of sine of x over 1 plus y. That's what this looks like, kind of. Obviously here, where y equals 0, or y equals 1, or maybe y equals -1 here, because that's where this would be undefined. We have some sort of continuity issue in there. So that would make sense that we would have that kind of issue in there. Anyways, let's try another example with implicit differentiation. Differentiate implicitly to find partial z, partial x. So we're differentiating with respect to x. So we've got x cubed plus y cubed plus z cubed plus 6xyz equals 1, right? There's no way to really solve explicitly for z. We don't really want to do that. So instead what we'll do is we'll just differentiate, use implicit differentiation. So basically, when we're doing implicit differentiation for partial derivatives, and we're differentiating with respect to x, we're going to treat y as a constant, so this thing doesn't really matter too much. So when we differentiate this, obviously here we get 3x squared. We differentiate this normally. And then we differentiate this as well, so 3z squared, but then we need we're using the chain rule, so then we get dz partial z partial x as well. And then here we've got to use the product rule, because we've got a product 6x times 6z. Y is constant, so we get 6xyz plus 6xy partial z partial x equals 0. So then we can move everything to both, or we can move all of our terms to the correct side, then factor, then divide. And what we get is partial z by partial x equals -x squared plus 2x, or plus 2yz over z squared plus 2xy. And this is what we've been trying to take the derivative of. As you can see, this isn't really a function here, but it is helpful to know how to take its derivative. So that is implicit differentiation and chain rule differentiation for multivariable functions. In the next video, I want to cover higher order derivatives. Then after that, we'll be moving on to some applications like tangent planes and stuff like that. See you in the next video. Bye.